Welcome back, West County students. This is Introduction to Waves. So in your notes, you should put Chapter 9, Introduction to Waves. Section 1, the nature of waves. Section 2, wave properties. Section 3, the behavior of waves. We will not be doing KWL for this chapter, so please just write what the big idea for Chapter 9 is, and that waves transfer energy from place to place without transferring matter. Our main ideas for Section 1, write it down. Waves travel through matter as energy is transferred from particle to particle. Section 2, wave properties depend on the vibrations of the wave source and the material in which the wave travels. Section 3, waves interact with matter and with each other. As always, you do not need to write essential questions down in your notebook. If you would like to, you may. It is your notebook. You can always just refer to this video if you don't want to take the time to write it down. As long as you can answer the essential questions, you will be fine and taking the test. And don't forget, you will need to actually be able to apply them, not just know the definition. So starting us off on lesson 9.1 for the nature of waves. Write down section point 1, nature of waves, and the main idea of this section is waves travel through matter as energy is transferred from particle to particle. So, waves and energy. Write it down. A wave is a repeating disturbance or movement that transfers energy through matter or space. Don't write the next couple things down. So I just want to talk. So for example, when a pebble falls into a pool of water and ripples form, or because it's moving, the falling pebble has energy. So as it splashes into the pool, the pebble transfers some of its energy to nearby water molecules, causing them to move. What I do want you to write down underneath this part right here is what you see is energy traveling in the form of a wave on the surface of water. So our last heading was waves and energy. Now, as you can see, we're on waves and matter. So after writing down the heading, waves and matter, please write down all waves transfer energy without transferring matter from place to place. So imagine you're in a boat on a lake. Approaching waves bump against your boat, but they don't carry it along with them as they pass. So the waves don't even carry the water along with them. Only the energy is carried by the waves. So write this down. Only the energy is carried by the waves is transferred. So in your book on page 275, you'll see this picture here. Okay, and you'll want to study that because this is a big part of this section and the chapter as a whole. And we'll actually be in this unit for about 3 or 4 chapters, so it's not going to go away on your test, so might as well learn it now. So let's just talk. Suppose you're holding a rope at one end and you give it a shake. You would create a pulse that travels along the rope to the other end, and then the rope would be still again. It is the up and down motion of your hand, that creates the wave. Anything that moves up or down or back and forth in a rhythmic way is vibrating. The vibrating movement of your hand at the end of the rope created the wave. In fact, all waves are produced by something that vibrates. So now that we've read that, I want you to write down in your notes, making waves. And this is all I want you to write down for a bullet point. Anything that moves up and down or back and forth in a rhythmic way is vibrating. And the second bullet point, this part, all waves are produced by something that vibrates. So we have a lot of new vocabulary words, a ton, and some of these you have never heard before. So if you don't start studying tonight, you're going to be behind for this exam. It is not an easy exam, so make sure you're studying. The next heading, mechanical waves. So what is a medium? Notice we have a vocabulary word. It's the matter the waves travel through. So the medium can be a lot of different things. It can be a solid, a liquid, a gas, or it can be a combination of those things. Next bullet point for your notes, not all waves need a medium. Some waves, such as light and radio waves, can travel through space. Waves that can travel only through matter are called mechanical waves. And there's two types of mechanical waves. You need to know these both, transverse and longitudinal. We'll be having a lab over these two, so make sure you read up on that in your book, please. Next heading, transverse waves. Write it down. In a transverse wave, matter in the medium moves back and forth at right angles to the direction that the wave travels. So just talking for a second. For example, a wave on a rope travels horizontally this way as the rope moves vertically up and down. So the motion of matter is going up and down this way as the wave moves through horizontally. And you can learn more about this on page 276. Water waves is our next heading. Water waves are not purely transverse waves. You need to know this. A water wave causes water to move back and forth as well as up and down. Water is pushed back and forth to form the crests and the troughs. I'm on page 276 of your book. This diagram can be found there. So you do not need to draw the diagram. It's clearly in your book and you can just use that, and that will save you some time on your lesson notes. But I do want to talk more about water waves and add this to your notes right here. The low point of a water wave is formed when the water is pushed aside and up to the high point of the wave. The water that is pushed aside returns to its initial position. Bullet point, please write it down. Ocean waves are formed most often by wind blowing across the ocean's surface. And in addition, the size of the wave that is formed depends on the wind speed, the distance over which the wind blows, and how long the wind blows. Those three things make up the size of the wave. Make sure that you know it's all three. So here is a depiction of a water wave. So when you have a force that pushes down, you can see what happens. Okay, so we have a force that pushes down and it moves along horizontally as well as going up and down. So it's moving back and forth as well as up and down. Our second type of mechanical wave is called a longitudinal wave. So you're going to be writing this whole thing down. You do not need to do anything as far as the picture because it can be found in your book on page 277. In a longitudinal wave, matter in the medium moves back and forth along the same direction that the wave travels. You can model longitudinal waves with a coiled spring toy like a slinky. Squeeze several coils together at one end of the spring and then let go of the coils to see what happens. Next bullet point, as the wave moves, it looks as if the whole spring is moving toward one end. The wave carries the energy, but not the matter, forward along the spring. Longitudinal waves also are called compressional waves. So you can pull it out, but then you can compress it right here. And you can pull it out again and compress it. If you've ever had your blood pressure taken and it squeezes and it gets really, really tight on your arm, that's the squeezing effect and it's called a compression. Next heading, sound waves. And we're going to have an entire chapter just on sound waves. Sound waves are longitudinal waves. So when a noise is made, you'll write the whole thing down. When a noise is made, such as when a locker door slams shut and vibrates, nearby air particles are pushed together by the vibrations. The air particles are then squeezed together like the coils in that coiled spring toy, and when you make a longitudinal wave with it, the compressions travel through the air in order to make a wave, which makes sound. So we're still talking about sound, but now we're talking about sound in other types of materials. Remember, different types of mediums. So sound waves can also travel through other mediums such as water and wood. I know that all of us as children have been under the water and said, hey, to our buddy, see if you can hear what I said to you, and we'll try to talk through the water, okay? Or maybe tonight when you're in the bathtub, put your head under the water and clink, clink, clink on the side of the bathtub, or snap your fingers and see if, hey, I can hear that, but it does sound a little different. So make sure you're writing these 3 bullet points. When a sound wave reaches your ear, it causes your eardrum to vibrate. So your inner ear then sends signals to your brain, and your brain interprets the signals as sound. Next heading, seismic waves. And again, you will not need the picture because you have it in your book. It is on page 278. So write this down. Forces in Earth's crust can cause tectonic plates to suddenly slide past each other. And this sudden sliding between tectonic plates produces seismic waves that carry energy outward. Third bullet point, seismic waves are a combination of longitudinal and transverse waves. They can travel through Earth and along Earth's surface. The more the crust moves during an earthquake, the more energy that is released. And we'll be discussing this more later in the year when we are on our Earth unit. And that wraps up our introduction for Chapter 9 as well as Lesson 9.1.